Dear friends, welcome back to the series of videos on everything you wanted to know about fully fashioned knitting. In the last video, we discussed that if waxing the yarn will help in reducing the occurrences of mending and improving the overall quality of knitting. We discussed and came to a conclusion that with a probability of around 50% or less, that the waxed part will be contacted at all, and that too for a time of 10 milliseconds. The chances of getting an appreciable effect are minimal. In this video, we will discuss why does the yarn break during knitting? If we understand the reasons why does the yarn break during knitting, we can then try and find solutions that will minimize the breaking of yarn during knitting, and thus improve the overall quality of knitting. A spun yarn is a strand of fibers laid parallel to each other, with a twist, so that the fibers do not slip past each other. This twist imparts strength to the strand of fibers, so that the yarn can hold itself firmly when subjected to some stretch during the making of a fabric using the yarn, be it weaving or knitting or any other method. Without this twist, the fibers will not be able to hold together firmly, and will surely slip past each other. Before we try to learn why and how a yarn breaks during the knitting process, it will do us a lot of good if we first learn how a yarn is made. How is the yarn spun? Yarn production is a process of converting fibers into yarn. It consists of different processes. Most known procedures are ring spun, cotton carded, ring spun, cotton combed, open end rotor spun, worsted spinning, woolen spinning, and air jet spun yarns. The process of spinning is to convert short and thin fibers into long threads. To obtain this, the spinning machinery lays the fibers parallel to each other, and then twists these fibers to make yarn. The raw material for spinning mills is fibers which are in random arrangement, and before the yarn is finally spun. All preparatory procedures have three objects. One, to lay the fibers parallel to each other, and second, to reduce the number of fibers per cross section, and to keep the number of fibers as uniform as possible. In the final stage, these strands of fibers are finally drafted to the desired yarn count. And finally, a twist is imparted to get a yarn with desired strength. The so produced yarns are doubled to improve the evenness and strength. This is done on doubling machines, and the doubled yarns are good, especially for flatbed knitting. So, how the spun yarn breaks? Let's see. Normally, a spun yarn will break when it is stretched to an extent that it cannot be stretched anymore. When we stretch the yarn and break it. In the normal course, a twist spun yarn, about 40 to 60% of fibers break, and the rest slip away. This is because the fibers in the core of the spun yarn have much lower twist as compared to the outer surface of the yarn. Therefore, the fibers at the core of the yarn get ruptured first. The twist that gives strength to the yarn, which is good for a particular number of fibers, is not effective anymore, as the number of fibers in the cross-section reduce because of breakage of the fibers in the core of the yarn, and thus the remaining fibers slip off. If we enlarge the picture, we can see that all fibers are not broken. A few are broken, and the rest of the fibers are not. If the yarn is broken on a knitting machine outside the knitting area, it will always break like this. A yarn will break outside the knitting area if there is an obstruction in the path of the yarn from the yarn cone to the tip of the yarn feeder. What we see here is a cone with no base, and this will definitely break the yarn, as the yarn cannot be pulled From the base of the cone. This is another way a yarn may break. If you look at the picture minutely, you will see that the fibers on the surface are turned back, leaving the fibers in the core exposed. As these fibers are lesser in number, they have broken. The fibers turned backward clearly show that the yarn could not pass through the yarn feeder tip. The hole in the yarn feeder is big enough to let even yarn. That is 2.5 times to 3 times bigger in diameter than the regular yarn. But with wear and tear, these yarn feeder tips get grooves at the end of the feeder. These grooves restrict the yarn passage, and when yarn gets stuck in the groove, it holds the surface fibers, whereas the rest of the yarn is still passing through. Because of the pull by the knitting action, the reduced number of fibers at the core of the yarn are not strong enough as regular yarn and thus break. If you ever see this kind of yarn breaking pattern, check the yarn feeders. But how does a yarn break? On the knitting machine. In the knitting area? There are 3 main reasons for the yarn breaking in the knitting area. First, the yarn has a faulty knot that is big enough not to pass through the knitted loop. Second, is because of a slub on the yarn, big enough not to pass through the knitted loop. The third, the yarn still breaks. At times, even though there is no knot or a slub on the yarn. When a yarn breaks in a knitting area, all fibers are broken. In this case, the knitting was being carried out using 2 ends of doubled yarn, which means all 4 yarns broke at the same spot. In the normal course, 2-end double ply yarns will never break like this on a 12-gauge machine. If a yarn breaks like this means that all fibers break within the distance of 2 mm maximum, 2.12 mm to be precise. If we hold the yarn 2 mm apart and try to break it, it will take a lot of force to break the yarn. The third reason, which is not because of the knot or a slub, but it is still because of the yarn. And this time it may be because of the yarn package density. And for that, we need to fully understand the process of the knitted loop formation. In simple words, we describe the process of knitted loop formation as when a new strand of yarn passes through the previously formed knitted loop, a new loop is formed. This is the tip of the iceberg. The fact is that the yarn goes through a lot of stretching during the knitting process. And when the yarn cannot take any more stretch, it breaks. The yarn that is used to knit has already gone through a lot of stretch. The reason for this is that the spinner wants to ensure that the yarn you get is not too weak. And at the same time, the spinner wants to reduce the logistic costs by making the final package as tight as possible. And in the knitting factories, we again rewind the yarn. This rewinding, if not done properly, and if a tighter cone is made, which happens in reality, stretches the yarn even more before the knitting process has started. The tension on the yarn keeps adding till it finally gets knitted, starting from the cone, from where it gets unwound. Though the unwinding of yarn from the cone is carried out from the top of the cone, which is technically called nose unwinding, the yarn is subjected to tension. This is caused by the abrasion of the yarn on the cone. If the unwinding is done slowly, if the yarn is unwound at a fast speed, the yarn will have a ballooning effect, which will impart centrifugal force, adding stretch to already the stretched yarn. Once the yarn is unwound from the cone, It passes through a few yarn guide bends, yarn tensions, and spring breaks. As shown in the figure, every bend and guide imparts some tension to the yarn. The yarn is fed to the knitting needles through a yarn feeder and passes through yarn guides, yarn control devices, and yarn deflectors. Every bend in the yarn path amounts to some further tension in the yarn. It is evident from the illustrations that by the time the yarn is fed to the needles, as the needles descend the stitch cam, the tension required to pull yarn from the package increases rapidly. The tension on the yarn is determined by the yarn/metal friction and the number of angles of the yarn wrap. Thus, a twofold increase in yarn/metal friction can cause a sixfold increase in maximum knitting tension. The tension also increases as the new loop formed passes through the previously formed loop. The tension also gets added because of the fabric takedown force. The fabric takedown force is continuously pulling the fabric down, along with the previously formed loops. The new loops pass through these previously formed loops. The needles keep pulling these loops upwards, and the entire force exerted by the fabric takedown motor eventually is borne by these new loops. The pulling of the yarn by the needles to form a new loop, the pull of the fabric takedown, all result in stretching the yarn. When the yarn gets stretched by these forces to its limit and a little more, the yarn breaks, resulting as a ruptured fabric. If you look at the illustration, it is clear that only needle number 1 can pull yarn from the yarn feeder. Needle number 2 needs to pull the yarn, as it is still going down to form a new loop. But there is no way that needle number 2 can pull the yarn from the yarn feeder. So it is pulling the yarn from needle number 1. And in between the needle number 2 and the needle number 1 is the sinker and the needle bed verge bit. This additional bend of almost 360 degrees creates more stretch in the yarn. The same goes for the needle numbers 3, 4, 5, and 6. This pulling of yarn by the needles from the previous needles creates a lot of tension and stretches the yarn. At times the yarn gets stretched to an extent that it cannot be pulled anymore. It breaks. Most probably, the yarn breaks in between the 4th to 6th needle. But here all the fibers in the cross-section break within the distance between the two needles. And this requires a lot of force, almost 2.5 times the force that is required to break the yarn normally. Because all fibers break and not only 40 to 60% break while the rest slip away. For a 12-gauge machine, the distance between these needles is 2.12 millimeters. Even when there is no knot or a slub is present, the yarn breaks. It is entirely because the yarn cannot be stretched anymore. A softer package of yarn, cone that is not too tight, has more relaxed yarn than a tighter cone that is more densely packed. Can surely provide a little more elongation to the yarn, when required, and can reduce the occurrences of such yarn breakages during the knitting process. The question here is, are these faults avoidable? The answer is yes. If we keep the yarn winders and yarn guides of the knitting machines clean, this will eliminate slubs of yarn fly waste. If we keep the yarn passage clear of any obstructions by threading the machine in the right way, and by checking and wear and tear effect in the yarn passage, including the yarn feeder tips, if we learn to make the right knot, and if we learn to set the small and big knot catchers in the right way, and finally, make the cone with a lesser package density, we surely can avoid this unwanted yarn breakage during the knitting process. Wait for my next video on how to set the right package density for reducing the mending in flatbed knitting. For more detailed information, you may go through my book on fully fashioned sweater manufacturing. A Guide to Fully Fashioned Sweater Manufacturing. Published by Woodhead Publishing India Private Limited. The book is available in leading bookstores in almost all countries around the world. It is also available on Amazon. If you have liked this video, please don't forget to click the like button. And, if you have found this video useful, please share this video as much as you can with your friends and colleagues. If you have not yet subscribed to this channel, please do not forget to subscribe to the channel. By subscribing the channel you will automatically get notification of the next uploaded videos. Thanks for watching.